My topic is energy based performance analysis of a turbojet engine. Introduction to turbojet engine. A recently established methodology is adjusted for standalone jet engines to enable a direct assessment of the traditional thrust based performance of aeronautical vehicles in terms of entropy creation. This approach is used to analyze a single spore turbojet engine layout to offer full traditional engine performance data for on and off design engine operation, a generic compressor for performance map, and simplified component performance characterizations are first used. The performance losses associated with this entropy creation are examined after details of exergy destruction in engine components across the entire engine and in the engine wake are supplied. Continues. The engine working envelope is determined by operational ranges of flying Mach number, altitude, and fuel throttle setting, and the results are reported across that range. The impact of wake losses in the engine wake on the corrective quantitative characterization of actual performance losses associated with the operation of a turbojet engine is demonstrated to be dominant over other losses, including all losses that occur inside the engine, specifically across the engine's working environment. The ratio of energy destruction in the wake to energy destruction inside the engine itself ranges from 1 to 2.5. Basic turbojet engine. Here is the first part inlet, second part post compression, post combustion, after turbine, exhaust. Turbojets are the oldest kind of general purpose jet engines. Turbojets are rotary engines that extracts energy from a flow of combustion gas. They produce thrust by increasing the velocity of the air flowing through the engine and operate on Newton's law of motion. For every action, there is an equal and opposite reaction. Working principle. Air is drawn into the rotating compressor via the intake and is compressed to a high pressure before entering the combustion chamber. Fuel is mixed with the compressed air and ignited by a flame in the idea of a flame holder. Hot combustion products leaving the combustor expand through the turbine where power is extracted to drive the compressor. The gas stream exciting the turbine expands to ambient pressure via propelling nozzle, producing a high velocity jet in the exhaust plume. Engine performance parameters: thrust equation, efficiency, specific fuel consumption. Thrust equation. In this, F equal to ma mvj minus vo. F equal to thrust in lbs, m mass flow rate of lbs by seconds, vo is the incoming air, and vj exhaust gas velocity. Factors affecting thrust. The jet engine is much more sensitive to operating variables. Those are engine rpm, size of nozzle area, weight of fuel flow, amount of air blade from the pressure compressor, turbine inlet temperature, speed of aircraft, temperature of the air, pressure of air, amount of humidity. Efficiency. The propulsive efficiency formula for air breathing engines is it can be derived by setting this general equation and assuming that m exhaust equal to incoming. This cancels out the mass flow and leads to np equal to 2 by 1 plus v9 by vo, where v9 is the exhaust equation velocity and vo is the airspeed at the inlet and flight velocity. For pure jet engines, particularly with afterburner, a small amount of accuracy can be gained by not assuming the intake and exhaust mass flow to be equal, since the exhaust gas also contains the added mass of the fuel injected. For turbine engines, if makes a significant difference to the computed propulsive efficiency. Overall efficiency, the product of thermal efficiency and propulsion efficiency. In the case of aircraft that generate thrust using propellers, when NPR is the propeller efficiency, thrust specific fuel consumption. It is the formula for thrust specific fuel consumption. Advantages of turbojet engines: very high power to weight ratio, compact than most reciprocating engines of the same power rating, fewer moving parts than reciprocating engines, low operating pressures, high operation speeds, low lubricating oil cost and consumption. And the disadvantages: cost, longer startup than reciprocating engines, less responsive to changes in power demand compared to reciprocating engines. For pure jet engines, particularly with afterburner, a small amount of accuracy can be gained by not assuming the intake and exhaust mass flow to be equal, since the exhaust gas also contains the added mass of the fuel injected. For turbine engines, if makes a significant difference to the computed propulsive efficiency. Overall efficiency, the product of thermal efficiency and propulsion efficiency. In the case of aircraft that generate thrust using propellers, when NPR is the propeller efficiency, thrust specific fuel consumption. It is the formula for thrust specific fuel consumption. Advantages of turbojet engines: very high power to weight ratio, compact than most reciprocating engines of the same power rating, fewer moving parts than reciprocating engines,